this idea is not new, so I was promising it for a long time because on ULX3S boards we have FTDI chip, which is used, let's say, a little bit hackish way in order to generate the bit banking for the JTAG through some kind of applications which is called UIPROC or FUIPROC, or some others has also adapted very successfully this protocol, like OpenFPGA loader, and it kind of works for free platforms like Windows, Linux, and Apple. But from time to time we have some issue. Okay, I have Macintosh, I cannot program your board. What's my problem? What is it? Is it done? Sometimes it can be some issues. Okay, difficult compatibility between the JTAG, some timing issues, software latency, and so on, and JTAG doesn't work. So we had some idea, that's even for a long time ago, idea about using the latest models of the ESP32, especially ESP32-S series like S2 and S3, to have and to replace USB FTDI chip with functionality from the ESP32. And first I get a S2 chip, and this S2 chip, okay, I managed something, but I was not quite satisfied with this because it was not very clear to me. Do I have some hardware, direct hardware JTAG? I can port my ESP35 programmer, but JTAG would be nice to have some kind of a built-in. And recently, maybe a month or two, I was reiterating this idea and find out that on the market exists something called S3 chip. It is more than S2. S3 chip has a lot of capabilities about the USB. It can have, let's say, custom-made USB inside. It has something that boots as power-up default, and it presents some serial port. But you can also program it to become anything like mouse, keyboard, custom device, or reverse role, so it can either be a host or device and everything else. But I was wondering, does it have some kind of a JTAG? Yes, it has some kind of a JTAG, but it is generally intended by the manufacturer to use it as its own debugger, to access its internal JTAG. So my other question would be, can this internally JTAG made be external? And then it was not so easy to find, but I found something. It is not documented by the manufacturer, but the rumor says it can be done. For example, ESP-C3 chip has it documented by the manufacturer, but this documentation is not the same for the S3. So somebody kinda, how can I say, posted on the forums. There are some kind of a special configuration data that you can enter to the S3, and it will become external JTAG. So I tried, and it works. And we know for S3 and the C3 chip, sequence of the commands which made JTAG to be external. Then it's not so easy afterwards. You will have some kind of obstacles. There is OpenOCD, some kind of actually patch for OpenOCD that Espressive, manufacturer of ESP32, released in order to use their own JTAGs. But if we want to program the FPGA with this tool, it won't work. It will fail at this command, run test idle, because normal JTAG processor doesn't need it, but FPGA needs it very often. So I was invested it a little bit and I found some kind of a patch that fixes it. And I posted on this GitHub. There is a patch to the patched OpenOCD, which makes it work. So it's proof of the concept. I told this idea to the author of Open FPGA loader project, and he has it on the to-do list. We have some branches that detect ID, but Open FPGA loader is not yet ready, but I hope so. The basic things we know it, and then it's just some work about USB packets. If we patch the patch to OpenOCD, if we use this configuration, we can make SVF file from the compiler and load it. So this is our bitstream SVF, and it will be programmed in our ULX32 boards. Here is a small, how can I say, proof of the principle example. Here is one very small SID Studio ESP32-S3 board, very little, 14 pins, just enough for the JTAG, and additionally SD card. So I also checked if the SD card is working, the programming is working. This is quite handy and nice. I think also a good, but we haven't tried it yet. I think the S3 modules are pin compatible with the classic S3 that we are using already on our board. So maybe it's not pin, how can I say, pin efficient. Some pins should be connected which we didn't connect, but I guess for the early trying it's possible to just solder this. This is our next try. I don't promise it will work, but I think there are chances to do it. And with a little bit reshuffling of the board and everything, we can make a board. My idea was to make, let's say, multi-purpose board that can be, if wanted, board can be soldered with a normal FTDI chip and classic ESP32. For example, classic ESP has normal Bluetooth classic. S3 doesn't have Bluetooth classic, has only Bluetooth low energy. If this one before has all the Bluetooths and old and new one. This is the only what we will lose on new one, but on a new one we will gain USB. It's much faster. It's maybe about 5 times faster than originally ESP hack of the FUIPROG and so on. So I guess we will have some kind of fun with the new boards. So this is it for.
So the first USB will be connected to the ESP32, and then we will from that console.
Yes. The first USB should be bypassed to the unsoldered, let's say, FTDI, which doesn't exist. We should have some kind, I don't know, jumpers or however it is practically done to go directly into the C3 chip. I have also some idea. I had can you see another one? Let's see another one project. This is my standard ESP32 ECP5 project that is by default loaded in all our boards which we ship. In this project we have MicroPython executable, okay, or better to say MicroPython source, less than 1,000 lines, which is called ESP5 Python, and it is a programmer for the JTAG and for the flash for ECP chip. I also have ported this for Xilinx and Altera. maybe it's not 100% all the features on these two, but I think it can be also used there. What I did recently for this S3 chip is called this DFU. So this is USB DFU programmer running on MicroPython that you can start and then plug to the USB. It will register, yes, I am USB DFU device, give me some DFU. You can use any compatible DFU, Windows, Macintosh, Linux, what you want, and just push it bitstream. You can push the bitstream into the RAM of the chip and bitstream into the flash. Both options are work. It's not directly compatible with our USB DFU loader, which we have realized in FPGA, but I am considering to make them compatible. I'm thinking to update FPGA part, because this DFU code is slightly newer. It has some kind of more fresh options. And this DFU is that. I found some already DFU example and just modified to call ESP5 programming, and 400 lines. You know, this new S3 chips has built-in PSRAM inside, so there is no longer issue for the MicroPython. The original one without PSRAM is very tight with the memory. But this is a past. On our new boards we are shipping the one which has a good enough portion of PSRAM, but these S3 chips are by default full with RAM enough, so MicroPython is not issue, is running very fast. One of the problem is, or let's say not the problem, but slightly incompatibility. I would like to compile MicroPython to expose also the native JTAG, which is available on the default ESP32-S2, but on current MicroPython that you can binary download, this JTAG is not available directly. So I need some kind of knowledge how to compile it. I think, but I didn't try. The C3 chip has such binary of MicroPython compiled to have this built-in JTAG. So I'm planning to try C3 just to see on the MicroPython is it there, and if it is there, then I will check what options did I compile it. Then I will compile the MicroPython. In my final idea, it should expose hardware JTAG to the external pins, so it will be fast and nice and compatible for programming, and it will still run MicroPython, so we can have FTP, other programming like command line, can run DFU and so on.
Cool.
Yeah.
And Jim, do you have some questions, or someone else from Discord? I think no one is currently asking you questions.
No one is logged on. Ferrari. Yeah.